This is example 2 for the COSMOSXpress lesson. To begin example 2, again we need to have our starting point file opened and saved in your own personal working directory. Now in this example we're going to be looking at how we can apply a force in a direction other than the direction that's normal to the face that we've selected as the face that's having the load applied to it. So again, for example, if we were selecting this face, by default the force would be coming down straight vertically. But we'll be looking at how we can apply the force in a direction other than the direction that's normal to that face. Okay, so the first step to completing this exercise is to go ahead and select the COSMOSXpress Analysis Wizard. We can select Material, and again we'll leave the default material of 6061 aluminum alloy. We can select Next to go to the next tab, or we can select the tab on the top. This is telling us that we're adding a restraint. We'll select Next, and we can apply our restraints. Let's select the box, move our dialog out of the way so we can zoom in, and we'll be restraining this part by the bolts. Once we've got those faces selected, we can select Next. We have no need to add any more restraints, so we can select Next. We'll select Next again. This time we'll be applying a force, so we can select Next. The load, in this case, we're going to apply two loads. So we'll apply a vertical load onto these faces, and then select Next. This load will be in pounds, 15 pounds of vertical load, and this load will be distributed over the two faces, so that'll be 7.5 pounds for each face. Had you wanted it to be for each face, you'd have to add two loads. One load to this face of 15 pounds, and another load to this face of 15 pounds. However, that's how we want it, so we'll select Next, and then we'll add a second load. Again, it will be a force, so we can select Next, and this one will be our horizontal load. This time when we select the face, we're going to select these two pins. And now by default we can see that the force is just driving in towards the pin. And that's not really the way the force is going to be on this part. So we're going to select Normal to a reference plane. Let's make our planes visible. And then I'm going to select my top plane. So now we have the loading going normal to that top plane. Had we wanted that to be on an angle, we could have created an angled plane and then had the force going normal to the angled plane. But we can see that we can select another face to be the normal to direction for the loading. We'll select pounds, and this time select 25 pounds. We can also see we can flip the direction that the loading is coming from. Let's select Next. We've got the two loads that we need, so we can select Next. We now have enough information to run the analysis. So yes, let's go ahead and run that analysis. Presently the mesh is being generated. And we can see that based on our parameters, the lowest factor of safety is 0.8. Let's go ahead and show us. I'm having difficulty finding that red spot. So if we say Next, let's not optimize the design just yet. Look at the results and look at the stress distribution. Let's look for the areas that look like they're in high stress. And it looks like our highest stress is down here where the part bolts down. We can see that the angled load has caused it to tweak a little bit horizontally as well as vertically. And again, remember that this is just a graphical representation. It's not measurable data as far as distance goes. Had you wanted measurable data, we'd want to say, show me the displacement of the model, and then select Next. And now we can see that based on the color, we can go to the chart and read the actual displacement. Noting the decimal place has to move 3 places. So at the worst possible scenario, we've got 80 thousandths of an inch of displacement. It's at the tips of this part.